So we're going to look at this little quiz that we did yesterday and try to get you the right answer. You should have the actual sheet, don't you? Didn't you get the sheet yesterday?
Yeah, we don't have our answers.
Why is it in your locker, Terry?
That's my other binder.
Go very fast. You need it. A 4-kilogram object is moving across a frictionless surface. Frictionless. With a constant velocity of 2 meters per second. Which of the following horizontal forces is necessary to maintain the state of motion? How many people took 4 times 2 and got 8? Nobody?
I don't remember what I answered.
Well, you know that this is the mass and this is the velocity. So why would you take m times v when the formula is F net is equal to m times a? Now, do we know the acceleration? We sure do. It's 0. Why is it 0, Courtney? Because it says constant velocity. So you would technically have to take 4 times 0, which gives you 0. The net force has to be 0. Why should the net force be 0? Because it's moving at a constant velocity. Remember Newton said, and I told you I was going to ask you this question over and over again, an object in motion stays in motion. You do not need a force to keep something moving. Unless, of course, there is what, Riley? Friction. Correct. But there isn't friction here. So how much force do you need? 0. The answer is 0. Did you get that right, Riley, yesterday?
I think I got 8.
Okay. At the very least, you should jot down the correct answer today.
Just
Number 2, what is the value of FF? A 20-kilogram box is gliding towards the right across the floor with an acceleration of 1 meter per second squared left. Which way is it moving, Natalia? To the right. But the acceleration is to the left. Okay, so we have a mass and we have an acceleration here. This is, in fact, the net acceleration, which is equivalent to 1. F net is equal to ma. Mass times 1, 20 newtons. It's actually minus 20 because it's to the left. But it's 20 newtons. Right? There are no other forces acting on it. It's 20 newtons. Does that make sense? I don't remember what the clickers asked for. Does anybody know if the clickers asked for? Maybe just see here. Maybe I can tell here.
You had to answer.
You had to answer. Adam had 20. He got it right. So it was just 20, I guess. Anybody put minus 20? You did, Mike?
Yeah.
Oh, you did.
That's because he's wrong.
You didn't mark it wrong, but you would be right, sir. Good for you.
You know what I want to see what you got.
20. Should we check the last one?
Yeah.
I put 8.
You put C.
You put C.
I put
You put 2.
it's on the order.
Mm-hmm. Okay. If the force is acting upon an object of balance, then the object must not be moving. Could that be true?
Yeah.
It could be true, but only if what, Courtney? If the force acting upon an object of balance, then the object must not be moving. That could be true if it wasn't moving in the first place. Wasn't moving in the first place. Must be moving with a constant velocity. That could be true, but only if it was already moving with a constant velocity. Must not be accelerating. That is your correct answer. Because it could be either one of those, right? So the correct answer is actually C. The correct answer is actually C. Number 4, an object, 20-kilogram object, will encounter a 50 Newton frictional force when pushed across a horizontal surface. With what force must you push the object in order to maintain a constant velocity? An object in motion will stay in motion unless there is another force. Is there another force here? Yes, there is. There's friction, so it will slow down unless you apply enough force to overcome friction. How much is friction? 50. How much force do you need? 50 newtons. You have to balance the friction.
Oh, yeah, it was
50 newtons. 50 newtons. You guys should have jotted down what you put
Oh,
on the sheet.
2.5. Yeah. We're way off.
Number 5, my friend Little Billy has a mass of 25 kilograms. How much force must be applied to Little Billy in order to lift him upward with a constant velocity of 2 meters per second? If you're lifting upward with a constant velocity, what is the net force? What is the net force? If it's a constant velocity, if he's going up at a constant force, the net force, you're right, Courtney, is 0. How much force is there down on him? It's mass times gravity. This one's a little bit tricky because I haven't shown you this kind of thing before. Mass times gravity, so it's 25 times minus 9.8. 245? Somebody help me out there. Mike, 25 times 9.8. You got a calculator right in front of you?
It doesn't work.
Terry's got a calculator right in front of him. 25 times 9.8? I think it's 245.
245.
245, thank you. 245. So how much force has to be applied upwards? 245 newtons. Want to see your answer? An automobile has a mass of 1,600 kilograms. What force is required to give an acceleration of 1.2 meters per second squared if there are frictional forces of totaling 200 newtons? Now this one is more challenging. I might even need to do this one here. We have a mass of 1,600 kilograms. What force is required to give an acceleration of 1.2 if there are friction forces? So friction is backwards at minus 200. I am asked for the applied force. If I'm given the mass and the acceleration, what can I get out of that?
Force.
The net force. So the mass is 1,600. The acceleration is 1.2. 1,600 times 1.2 is, Terry?
920.
So 1920?
Yeah.
I need 1920 newtons of net force. But I got friction at 200. Do I subtract 200?
Yeah.
No, Devin. We already went through this in an example. Remember this? Write the formula. F net is the applied force plus the friction force. The net force is 1920. What's the applied force? What we're looking for. What's the friction force? Minus 200. Take it to the other side. Applied force is going to be 2120. 2120.
I probably subtracted it. Or just didn't do anything.
Carly got it. Carly got it. Jesse got it. Kate got it. Very nice.
Wow,
Adam subtracted. So did Courtney. So did Mike. So did Jesse.
Damn it, I just didn't know what I was doing.
Okay. Well, do you think there's a good chance of that question being on the test? I'd say almost better than 100% chance.
That's not possible.
That's why I said almost. A body of mass of 15 kilograms rests on a frictionless surface and has 30 newtons applied to it. What acceleration is produced? What acceleration? 15 frictionless surface, 30 newtons applied to it. We got, well, not 50, 30 newtons, right? It's frictionless. What acceleration is produced? Hey, this one's easy, I think, isn't it? F net is equal to ma. I got 30 newtons. I got 15 kilograms. What's my acceleration? 2. 2 what? Meters per second squared. How'd we do? Oh, excellent.
Maybe I got it right.
Just one person. Very divided. Or you subtracted. Don't do that. What will its velocity be at the end of 8 seconds? Also, you guys did very well. How do you do that? You go A equals delta V over delta T. The acceleration was 2. The delta V is what we're looking for, 8 seconds. The change of velocity is 16. Therefore, My final velocity is 16 meters per second. How come delta V and VF are the same? Because the VI is equal to 0. The VI is equal to 0. The initial velocity is 0. So if it changed by 16, we started at 0, we end up at 16. Good. How many more we got left? How far will the body travel in 8 seconds? Oh, I'm going to guess a few people got this one wrong. A few more, yes. Okay. If the final velocity was it 16?
Yeah.
The final velocity was 16. Now in the formula that has distance in it, V bar is equal to D over T. Does V bar equal VF? Why not, Adam?
Because V bar is average velocity.
The average. The average. You can't just take the final velocity times the time. You've got to find the average. What is the average? VI plus VF over 2. Oh, that should be 0 plus 16, I guess. 0 plus 16 over 2. You get 8. And now you go 8 is equal to D over 8 seconds. D is 64 meters. 64 meters.
16.
Who got what here? Jesse got it, Adam got it, Riley got it, Carly got it, Kate got it. Okay, so make a note that you need to know how to do that kind of question.
16.
Number 10. The diagram below shows forces acting on cars that are moving to the left. The size of the force is denoted by the size of the arrow shown. In other words, the bigger the arrow, the bigger the force. Which cars would be undergoing non-uniform motion? In other words, which cars would be either speeding up or slowing down? Okay, well, let's just see here. There has to, for it to be undergoing non-uniform motion, there would have to be a net force. These ones are balanced. Are these ones balanced? There's the left right here. There's a net force there, isn't there? Which means there's an acceleration. Is there a net force here? Is there a net force here? Yeah, for some odd reason, this car has actually got a net force up on that one. It's rising. What about this one here? Yeah. In fact, all of them have a net force, and so the correct answer is D, all of them.
Yeah.
Okay, D, all of them. Number 11. A vintage car can accelerate in third gear from 80 to 100 in 4 seconds. The acceleration measured in meters per second is about. Now, it's in meters per second. Oh, it should be per second squared, shouldn't it? Do I have to convert my 80 and my 100? Because they're in kilometers an hour. Adam's nodding yes. Do I technically need to convert them?
No.
What could I do, Mike? You don't know? You could go 100 minus 80 is 20. The delta V is 20, and then convert that if you want. So you don't have to convert 2. You can do that. So Terry, take 20 divided by 3.6 for me, please. Convert it. Five? How about we say 5.6? 5.6 meters per second. 5.6 meters per second. Now, no, that's just the change in the velocity. What do I need to do now? A equals delta V over delta T. So I got 5.6. My time is 4 seconds. 5.6 divided by 4, Terry? 1.4. My answer is A. And we're a little bit all over the board here.
Yeah, lots of big B.
Lots of big B, probably because you took 20 and divided by 4, right?
Yeah.
If you picked B, then that's because you didn't convert to 3.6, which is what the vast majority of you did. A couple C's. I'm not sure how you get that 20.2. And number 12. Now, number 12 is the hardest one of the bunch. The catapult launching aid system on an aircraft carrier is a mechanical device that accelerates jet fighters across the deck up to takeoff speed in quite a short distance. A jet has a mass of 1,700 kilograms and needs to achieve a takeoff speed greater than 225. So this is achieved with a catapult system capable of pulling the jet with a force of 50,000 newtons. With these requirements, the minimum distance along the deck needed for a successful takeoff would be. In other words, how long does the deck on an aircraft carrier need to be? Okay, so we've got 50,000 newtons. Do you think friction plays much when you're pulling with 50,000 newtons? I don't think so. The mass of the jet is 1,700. With the mass and the net force, because this is the applied force, right? And there's no friction here; it's so small that it's meaningless. With the mass and the force, can I get the acceleration? Yeah, yes, I can. So F net is equal to ma. 1,700. Oh, sorry, 50,000. So Terry's going to go take 50,000 divided by 1,700. And what do you get?
29.4.
29.4 meters per second squared. That is pretty fast acceleration. Now we need to know distance. Before I can get distance, I need to know average velocity. Can I get average velocity from acceleration? Do I need a step in between? I sure do. A equals delta V over delta T. The acceleration is 29.4. I can get the change in the velocity. Good thing I'm using a pencil. What do I do, Riley?
You find the average velocity using VI plus VF, and then you divide it by 2.
But I don't have VI or VF. Oh, I do. I have the VF. I have the VF. You're right. I apologize. V bar is VI plus VF over 2. I do have the VF. So I got 0 plus 225 over 2. That I can do in my head is 112.5, right? And now with that, what can I do? Oh, I got to find, actually I can get my time with my A and my delta V, right? Oh, I'm glad Riley's here. 225. So I got to take, he's saying take 225 divided by 3.6. Do that for us, Jerry. Okay, so 31.25, divide that one by 2. Let me see if I can do that in my head. It's going to be 15.
It's 62.5.
Yeah.
Courtney. Making me look bad. 62.5, now it's 31.25. Okay, that just gives me my average. How do I get my time? How do I get my time? Not magic. What's my delta V equal to? If the initial is 0, and my delta V is, and my final is 225, isn't 225 equal to 62.5? My delta V is equal to 62.5. Now I can go delta V over delta T. By the way, this, yeah, you're going to have to do this, Riley. I hope you've been working at home. 29.4 is equal to 62.5 over my time. Here we go. Now I get my time. What's my time, Riley? 2.12. And now I've got average velocity. I got time. Now I go V bar is D over T. And I think I'm on the home stretch here. 31.25 is equal to D over 2.12. 2 and a little bit times 31 is going to be, what's that, 62, 60. It's going to be B, isn't it? What is that number here, Riley? Is it exactly 66?
I don't know.
Oh, you just get it.
0.25.
Okay. How many marks would something like that be worth? About 30. Let's just check here. 1, 2, 3, 4.
There's like
30
things you have to
30 things.
I can probably
Sorry.
count 30 things.
Actually, there's one more. I got to do that conversion there, right?
Like one, count all the numbers in there, and maybe.
You can count 33 things there, Riley. You come on up.
Oh, well, you're a tricky one.
You had better make sure you get how to do some of those questions because there is a test coming up real soon. We need to do the Newton's Law lab, And, oh, look at this.
Finish it in one then.
Many of you still owe me these, that's right. So in fact, I'm going to go and I'm going to yell at you right away. You got a little bit of time when everyone turns them in.
It's actually not that hard.